Yeah, hi, good evening, everyone. So, welcome to the week 5 open session. So, before starting this session, if anyone have any query, the course, good evening, sir. Any query? If you have any doubt? So, this week we are also starting this timed mock assignments, timed programming assignments. So, if you have any doubt regarding that, or yeah, this Friday we will conduct the revision session also. So, and we have also released this mock questions. So you can also visit the mock questions to get some idea of the quiz one paper or qualifier paper. Okay, so and also join the Friday revision session. If you have any doubt in first 4 weeks, then you can discuss. Otherwise, the all week for summary will be discussed in that session. So, but today's session is for week 5. So, we will summarize the week 5 contents in this today's session. So, if you have already watched the videos, and then you can also ask your query. So, we will cover that query in this session. Or if you have any other doubt, you can also ask before the session.
Sir, please explain recursion.
Yeah, recursion part. Okay, fine. Yeah, that part we will cover through the summary. So if you have any specific doubt in the recursion part, so you can ask in between. Okay, so well, but we will start from the basic function. Okay. Okay, any other query? So also this is important announcement that this week we are starting this timed programming assignment. So do not skip any assignments. Okay, so initial weeks timed assignments will be easy. So I think if you complete the first 3 timed assignment, then you will that qualify the criteria of the OPP2 exam. Okay, so do not skip the initial timed assignments. Okay, so try to complete all the timed assignments on time, and also just try to attempt in the initial slot. Do not wait for the last slot. Okay, so sometimes what happen if you are not able to due to some error or some regions, if you are not able to finish all 4 problems of the timed assignment in the time, so there is no chance to attempt again. So if you so just try to attempt in first slot. So if any problems left, then you can attempt in the next slot. Okay, and for ES, this actually timed assignment have 15% weightage. So this is important. Do not skip any problem, or also try to complete all the solution correctly. Okay, problems will be similar to your programming assignments, that weekly programming assignments. And first time mock problems will be based on the week 4 content. That means control statement based. Okay, so this week, Saturday and Sunday and Monday, 8 to 10 p.m. Okay. Okay, so then I'll start the share my screen.
Sir, where we open the timed assignment, where we get that?
On the portal itself. Okay, so suppose this is the our course portal. Okay, so here you can see all the unit week 0, week 1 like this. So
Yes, sir.
similarly on the given time. So suppose Saturday 8 p.m. So when you open this portal, just refresh the page. Okay, so if you one new unit will appear at the last. So after this supplementary content, so one new unit will appear.
Okay, sir.
Okay, so that name with the name of timed programming assignment as one like this. Okay, and
Okay, sir.
inside that unit you can access all the 4 problems. Okay, so suppose if you are not able to see the that unit at the time of 8 p.m., So just try to refresh the page. Okay, so just keep refresh the page. So maybe sometimes what happened, so that problems will be released after 2 3 minutes. So okay, so just keep refresh the page at that time, and then you can see. And interface will be the similar of your that regular programming assignments. Sorry. Okay, so yeah. Okay, now the week 5 content. Yeah, I've created this summary notes. I'll I have already pasted in the drive, which I have shared with you in the last calendar event. Okay, I have already shared the link of the drive, and I have stored the week 3 and week 4 also, and I have also stored this week 5. So I'll also paste the drive link in uh, this Google Calendar event. So, okay, so someone is. Yeah, I have a doubt in week 4 practice assignment question number 7. Okay, so yeah, we can take this the practice assignment question number 7. Okay, so let me open uh, this one. Okay, so what is the question? You are developing a program for the retail store that offers a discount based on the total purchase amount. Write a C program that takes the total purchase amount as input and print the final amount to pay after discount given as follows. Yeah, what is your doubt in this,
No,
sir?
sir. The practice assignment question.
Oh, this is okay. Theory assignment you are talking.
Yes, sir.
Okay, okay. So this one.
Yes, sir.
Okay. So in this question, we will just start from the first line, okay, and we'll check what value actually we are getting in the each variable and what updates are happening. So in this, hmm, the question is asking that what will be the output of this code, okay. So initially we are starting with I. We have three variables, so I and j and k, okay. And in so this is the first line we have just declared, okay. So all these three variables are integer data types, okay. So that means it will contain integer value. Next line, when we are writing I equal to j equal to 0, so this is the assignment uh, operators, okay. So we are using assignment operator in the continue in the chaining manner. So in this case what happened, the associativity of the assignment operator is always left to right, okay. So that means when we are writing this I equal to j equal to 0, so that means operation will be performed from left to right. So that means this 0 will be assigned to j first, okay. So that means j, so I'm writing here I j k. So this 0 will be assigned to j. So 0 will be assigned. Now we will replace this 0 at a place of j. So now this 0 will be assigned to I also, okay. So 0 will be assigned to I. So this is the impact of this line I equal to j equal to 0. Now next line is a for loop, okay. This line is a for loop, and what we are doing in this, so we are running a loop. So this is loop statement, it is given. And in this loop what we are giving, so for, and this is one colon, that means there is no initialization we are giving here, but we have already done initialization of I, okay. So in the previous line we have already initialized I equal to 0, and the condition of the loop is I is less than 10, okay. So that this is the termination condition, and each time we are incrementing I plus plus, okay. And inside this statement j equal to plus plus I, so this is also coming in this loop, okay, because termination is happening after this statement. So we can also write like this: j equal to plus I. Okay, so this loop we can write in this manner also. Okay, now if we run this loop, so initially our I value equal to 0. Okay, and we are so we are entering, so we are checking the first I 0 is less than 10. Okay, okay, correct. So we are entering inside the loop, and here what happening, we are performing pre-increment operation. Means we will use the value I in this operation. So this is j equal to plus I. Okay, so we will use the value of I after increment uh, in this expression. Okay, so first what we will do, first we will increment the I value, then we will assign to j. Okay, so this is pre-increment. So before expression, before computing the expression, we will solve this, we will increment this I, then we will assign to j. So I value is also incrementing inside this for loop. So what happened? So initially I equal to 0. So I will increment by 1 first. So I will become 1. Okay. And 1 will be assigned to j. So that means 1 will be assigned to j. And so I is incremented first time here. And next iteration I will also increment one time here. Okay. So in one iteration, this I will become 2, and at that time j is 1. Okay, okay, so we are not using k in this, so this k is additional. Okay, so this is the first iteration. Now again, now our I become 2, so 2 is less than 10, correct. Okay, now again, so 2 will the here we will increment first. Okay, so 2 will become 3, and 3 value will be assigned to j, 3. Okay, now I become 3, and one time increment here. Okay, so 3 and 4, so that means 4, and it becomes 3 here. So this is the second iteration, and at this time our okay, so yes, correct. So now 4 is less than 10, correct. So once again, so we will increment our j by okay, hmm. so 4 plus 1, 5. Okay, so j will become 5, and this I will become 4 plus 1, 5, and 1 here, 6. Okay, so in this manner this value is incrementing. Okay, so this is the next time 6 is less than 10. Okay, then again condition is true. Then our 6 plus 1. Okay, so 6 plus 1 assigned to j, so this will become 7 and 8 here. Okay, in the next iteration 8 is also less than 10, correct. So once again 9 here, 9 will be it will become 9, and I become 10. Okay, so at that time 10 is not less than 10, so now this condition is false. So we are not entering inside the loop, and this is the termination condition. We will come out of this loop. At that time, what is the last value we are getting for I and j? 10 and 9. So I think this should be the answer. Yeah, 10 and 9, correct? Clear?
Yes, sir.
Okay. So could you please provide the same summarized notes for week 1 and week 2 also, if possible? Please, notes are really.
Sir,
Yes.
sir, in the week four programming portal,
Huh.
I couldn't run or submit the program, sir. I'm facing the issue.
What issue you are facing?
Sir, I couldn't run or submit it again, sir. Only one time I just I press the run option, and
Okay,
it just
so
finished.
deadline. Okay, okay, okay. So I'll. Can you share your screen and show me
Yeah, I have posted in the Discord, sir, the
when you
image.
put? Okay, so let me. Where you posted? This is.
Sir, the first one, issue in portal, this one, sir. It's just showing like this, and I couldn't zoom out also, sir.
Okay, so this is graded or practice question?
It's practice only, sir. Practice fifth and sixth question, sir. Only these two
Actually,
questions are
what
facing me,
happening?
sir.
This is depends on your code. So what output your code is actually returning. So maybe your code is returning a very long output. So because of that, this page is distorted. Okay, so in this case, what you can do, you can just resize your browser from like this. You can go to this three dot, okay, in the top, and just zoom in like this. Okay, so zoom in, zoom out. Just you can try, then you can see the variable. Or if you have the code, then can you post in the chat? So I'll also check in my.
Yeah, okay, sir. I will try to
Yeah,
zoom in.
I have already replied to you, but after that you
Yeah,
did not reply.
okay, okay. Just now I saw this, sir.
Mhm. Okay,
Okay,
so
thank
just
you, sir.
paste
I
your
will do.
code and also mention the problem number. Then I'll check with my side. Okay.
Yeah, okay, sir.
Huh. Yeah. So Suruchita, so this week one and week two actually doesn't contains the programming component. So we have the notes. Okay. So we will share in the same drive. So, but also see the also watch the video. Okay. So do not skip the videos if you're looking this notes. Okay. Okay. So yeah, week 5. So now the week 5 we are learning the function and recursion. Okay, so these are the two. There is one more topic, scope. So we are learning these three topics in the week 5: function and recursion and scope in the C. So we will discuss today and we will summarize this content in the today's session. And these are the week 5 contents. So what is the function basically, and why this is needed, and what are the syntax we use for the function. So if we look the definition, so function in C programming are blocks of code that perform a specific task. So function is nothing but what we are doing, we are just creating a block of code to perform some specific task, and we are giving some name to that block. Okay, so in this manner you can organize your code in the better way. So or you can also reuse that block multiple times in your code. There's no requirement to write that code multiple times. Okay, so that will increase the code length in your code. So suppose if you know that if you are performing the one specific task multiple times in the code. Okay, so if you need to perform the same task again and again in the code when the code is running, so what you can do, you can make the separate block for that code, and you can give some name of that block. And when that specific task is required to run in your code, you can simply call by the name of the that block. Okay, so in this manner we can also arrange the code in the block fashions, and we can organize the code in better way. So sometimes what happen, so if we are if we are writing the code in block manner, so this is also easy to understand, this is also easy to maintain. Sometimes what happen, if we are getting any bug or any error in some specific part of the code. Okay, so but if we have declared the function for that specific task, so we need to update our function part only. Suppose if you are writing the same code again and again 10 times in your code, and after that you got this information that your code have some issue and some bug, so you have to modify your code at that all 10 place. Okay, but what we if we are writing the code in the function manner, in this manner, so we can update our function directly, and it will reflect for the each call. So function is just a block of code to perform some specific task. And what actually benefits we have for the function? So reusability. Okay, so first is the reusability. code, that part block of code can be used multiple times without writing multiple times. Okay, we will write the code only one time, one block, and we will call that block multiple times. Okay, so that means we are reusing the same code again and again in the code without writing multiple times. Okay, modularity, break down complex problems into smaller or manageable units. Okay, so what happens right now, you are writing a small you are solving very small problems. Okay, you are writing a very small solution code, but what happens when you work in the development company or when you're designing any application? So at that time you have to write a very big code, and your application may contains lots of functionality. Okay, so at that time you have to design your code in that way, so each functionality can be defined in by some uh, specific separate module. Okay, so you will just separate your big code into a different smaller modules, so you can also understand the code, which module, what is the working of the each modules, and at that time you can easily manage the all the modules. Okay, so same things we are doing with the functions, this using the functions, so we can break our big code into a smaller functions, so we can easily manage that code. Readability, so this improves the code organization and clarity. So generally we, when we write the function, so we also may give some name to the function, and that names is actually reflect very good meanings. So according to the purpose of that specific for purpose of that function. Okay, so we can directly look the function name, and we can understand that what the function is actually, that part of that block of code is doing. Okay, so we can easily understand that, and so we can easily organize the code. So last is maintainability. So I've already mentioned that if we need to change something, so we need to change in only one function, and that will be reflected in each call. So in this manner, so these functions, writing the code in function manner is a good practice for coders. So, what, okay, C function can be classified into categories, into the following categories. So, first is predefined function. So, predefined function is also we can categorize into two. One is standard library functions and external library functions. So, standard library functions, so that function which are actually standard, which are defined in C standard library. So C standard library means, so like this has include stdio.h, which you are using in this each program. Okay, so stdio, that means standard input output library. Similar type we also use the malloc.h, that and another library we also have for some specific purpose for dynamic memory allocations. So these function, if you are writing printf function, okay, so this printf, you are writing this function, this is also a function. Okay, so printf and round bracket, and you can pass some strings inside this function. So this function is already defined, predefined in the library of standard input output, which you are writing before the in the starting of the program, has include stdio.h. So in that library, this function is already defined. You are simply calling this function by the name. Okay, and that function is performing because it is already defined. And similarly scanf, okay, this is also is the input output function, which is defined inside the stdio.h. And same malloc, free, these are also some function which is defined, this is for dynamic memory allocation. So this is also defined in C standard library. Okay, so these function we can directly call and we can use when required. Okay, so at stdio.h, this is also mentioned here. So this stdlib.h, okay, so this also, this contains this malloc and calloc and free, this type of predefined function. Okay, so these are called function. After that, external library is also there. Okay, so sometimes what happened, we required some math functions, like, okay, for example, math function is very popular if you're writing the code to solve some math related problems. So you can directly perform some operation which is defined inside the math library. Okay, and sometimes like square root and that power, So there are many functions defined, cos, sine, like this. So these value you can so all these are actually function which is this sine, cos, and all are these functions are defined in this external library math.h. So that library you can include in your code using the same thing. So has include math.h. After that you can call the function which is defined inside this library in your code directly. Okay, and you can get the output according to that how that functions are defined. Okay, you can directly use this call this function, and you can get the output as per your requirement. Okay, so these are predefined function which is already defined in library, you can directly use. But what happens sometimes, we need to write some solution for the new problems where the functions are not predefined. So at that time in your code you need to write your function. Okay, so your function, and we generally called as user defined function. So here user is you, because you are writing the code. Those who are writing the code, those can define that function. Okay, those can just write the definition of the function, give the name of the function. Okay, similar to this predefined and standard library function, you can also give some name to the function for some specific task. So user defined function created by the programmer to perform a specific task within a program. Okay, so if you feel that part of that block of code, or that part of the code will be called multiple times, that will be performed multiple times, you can define your function and you can use according to your need. So similar, some example is given like here. So add, so suppose if you are getting two integer value repeatedly in your code, and you need to add these two values and return the sum of them, these two value. Okay, so if you are performing these things multiple times in your code, so you can define the function for that at the time. So if you need to add something, so you can call that function and you can get the answer. So similar multiply. So according to your need, you can define any type of function in the C. So now user defined functions. So what is the syntax, and how we declare the function and how we define the function. So okay, these are two different things: declaration and definition. So declaration means we are just giving the prototype. That means we are just giving the name of the function. We are just telling to the compiler that we will create this name function in our code, and what type of data we will take as a input, and what type of data we will return from the function. So this is just information to the compiler. Okay, so if we are declaring the function, so we called as a function declaration, or sometimes function prototype. Okay, the syntax of that function declaration is like this: return type. This is the data type value. Okay, so actually when we are writing the function, so our function may return something to the same code where from we are calling that function. Okay, so that function return some specific type of value to the same code where from we are calling that function. So we have to define what type of value our function will return. So that type we have to define here. So similar to your variable type. Okay, so that you have already learned that integer, char. Okay, this is that char, float, double, this type of data. So you have to also define data type of the function if you're returning something. Okay, if your function returning something, then you have to define. Otherwise you have to mention here void. So there is also one data type void, and that represent nothing, null. Okay, so void means nothing. So if your function is not returning, only performing some task. Okay, so in that case you can write only void. Okay, so void syntax and function name. So this is the first part. You have to mention the data type which you want to return from the function. After that, function name. So this is the second part, function name. Okay, so this is the second part. So function name is the same. We will follow the same rules for the function name which we are using for the variables rules. So same in the similar mean, you can give any name to the function. Most of the time we give the function name in the which actually may reflect the meaning of the function. So what function is actually performing. So some based on that we generally gives the name to the function. So we can easily understand by looking the name of the function. So what function is doing actually. Okay, so function name we can give, so you can define the name based on the variable rules. Okay, so you can like you cannot start the function name with the integer value, you cannot use some specific symbols. Okay, so same rules is applied for the naming of the function which we are using for the variable name. And after that we have this round bracket. Okay, round open bracket and round close bracket. Okay, so we will just put this open bracket and close bracket. Inside this, if your function is not taking any value as a input, so you can leave empty this. Okay, you can leave empty this. So at that time your function is not taking any input, so you can leave. If your function taking some input to perform some specific task, in that case you have to define the uh, data type of that input and the name of the parameter. Okay, name of the input. So what variable name you want to define here to store some input value. Okay, so this is suppose we are just reading some para input and we are giving some variable name to store for that input. Okay, so here parameter 1, parameter 2, these are the simple variable names. And what data type we will use for that variable, so that variable name will we will define before that parameters. Okay, that variable name. So parameter 1 type is parameter type 1, like this. Okay, so similar to this int well int float double, like this. Similar we can define any number of parameters inside this round brackets. So this is simply declaration. Okay, if we write and this is colon, that means we are declaring the function name, and this function we are just telling to the compiler what function name we are declaring, what type of data we will take as input, what type of data we will return from the function. So we are just declaring the structure of the function for the compilers. Okay, so after executing this statement by the compiler, so compiler will understand that there is one separate function is defined in the inside the program with this name. Okay, so this is just a declaration. So after declaration we also need to define the function. Define means we have to um, totally we have to give the definition of the function. Definition means we have to clearly define the function. We have to write all the statements which we want to execute inside the block of function. Okay, so this is the definition. So this is also a similar type of the declaration. So we have to also write the return type first, the function name, and same parameter type 1 parameter. So parameter 1 and what is the type of that, parameter 2 what is the type of that. So same things we have to define. After that we will just start with this curly brace, open curly braces, and this is the end curly braces. Okay, in between we will write our all statements which we want to perform. Okay, so this statements 1 2 3 like that. In that way we will just write the all statements, and that will be called as a function block of statements. Okay, so this block of statement will execute when we call this function. Okay, so function body, and generally we call this uh, block of statement as a function body. Okay, that body will implement when we call this function. So statement to perform the desired task. And there's one things optionally, this is not compulsory, so we can return some result from the function if required. Okay, so but this is not compulsory, so based on the need we can return something from the function. Okay, or you can leave also if you're not required. So this is the syntax for the function declaration and syntax for the definition. So now we will take some example to understand easily. So now these are the things we will define with the example. So here you can see one example is given. Okay, so this is now complete code, and you can see this is the first header file we have added in the code. And here we have defined, so this is declaration, so this is function declaration. We are creating one function with the name of add. Okay, we are giving the function name add. Okay, and we have also defined the return type of the function int. So that means when we call this function will return one integer value. Okay, so because of that we have written here int data type. And also we have also defined two parameter a and b. Okay, data type of a is int, data type of b is also int. So we have also defined the data type of int. So these are simple two variables which we have. So we will read, so this is the syntax. That means we want to read two input value for this function, and we will return one integer value from the function. Okay, so these are the two required input for the function, and we will return one integer value as output from the function. Okay, so this is function declaration. We have simply declare the function structure. After that we can write the definition of that function. So this part is actually definition. Okay, this is the main function. We always write this function. Okay, so main function is always required for the C. So this main function will all execute first. Okay, now this is the definition of the add. So same things, we are writing the declare return type, we are giving the name, and we also mention the parameter and data type, parameter and data type. So, and after we are writing the body. Okay, so this is called as a body of the function. Inside the body we are writing some statement. So this statement we are writing int result equal to a plus b. Okay, so one this syntax is missing, so just mark this. Okay, so int result equal to a plus b. So that means we are declaring one variable result, and we are assigning the value of a plus b into this result. Okay, inside this function, and we are returning the result value from the function. So this result, if you are taking two integers and you are adding these two integer, you will get the one integer. Okay, result, and that result value you are returning by the function. Okay, so this add function will return one integer type value. So this is our example of add function. So this is the definition. Okay, we have defined the function in our code. Okay, and this function is defined totally out of this main function. So main function is starting from this bracket, so this part here. Okay, but after that we are writing this main function. So you can also write definition before the main function. Okay, at that time, so you also need to declare the function. So this function declaration is not always required. So but in the old compiler, actually if you are defining the function after main function, so at that time if you are calling the function from the main function, so at the time the old compiler generally gives the error, because when the main function is running, at that time the function, that user defined function is not defined. So at the old compiler gives the error if you are not declaring the function. But in general, new compiler, the current compiler are more intelligent. So if you're not declaring the function, still your compiler will get this information, your function is defined after the main function, so it will call correctly. Okay, so without giving any error, so your code will run correctly if you're not declaring the function. Okay, or what you can do, if you don't want to declare the function, so you can define this function before the main function. Okay, so this part you can skip, but just do the good practice. For the good practice, just declare the function and define the function in later. So most of the time what we generally do, we write the main function at the top in our code. Okay, and we define all the function after the main functions. So because of that, we generally declare the function uh, before the main function. So in this case, so this is the definition declaration. Now next thing is the call the function. Okay, calling the function. So here we can call this function. So you can see the main code now. So int result. Okay, so this result, we are just writing one variable, and here result equal to add, we are calling. So this part is a calling function. add, we are giving the name of the function, and we are passing two values, 5 and 3. So this 5 value, when we are calling this function, so that means we are calling the below function, that block of code, where the 5 value will be assigned to a variable, okay, and 3 value will be assigned to b variable, and that value will be passed to the inner body, and your code, that part will execute with this input, okay. And after getting 5 plus 3, so 5 plus 3 8, that 8 value will be assigned to this result, which is defined inside the function, and that result variable value we are returning from the function, okay. So that means we are returning 8 integer, and that, so that means when we are calling this function, at the end this function will be replaced by 8, okay. So this function, when this function will complete, will return 8, so this 8 will replace the call, okay. And this, when you're writing result equal to 8, that means 8 is assigned to result here, so this result is separate variable, okay. So this 8 value will be assigned to result, and you are printing this result value, so 8 will be print into the output, okay. So this is the calling behavior of the function when you're writing the function, okay. So we can just trial this. So we'll check with this code, so like yes, this is the same thing. We can define the function, so like int add, and we are writing like int a comma int b, okay. So this is the declaration, okay. After that we can write the main function, so main, and so this main is also a one function, okay. But this is the first function which we are always calling, and out of this main function we can write the definition of add function, so we can write like the same manner, so int add, and same int a comma int b, and we will write the body for this, so like int, we can give any name, so res equal to a plus b, and return this res, okay. So this is the function definition. Now we will write the main function, so we are writing like the same manner, so int res ult, so this is the different variable, and we are calling this function result equal to add, okay. And we are passing like 5 comma 3, and after that we are printing this, so print percentile d and r result, okay. So this syntax we have written. So now when we run this, so you can see we are getting 8 in the output. So this actually, this print statement is printing this output in the output console, you can see, okay. So when we change and this value like 5, you can see the output will also change 10. So in this manner you can call this function from the print statement also. So suppose if you want to perform the same function multiple times, so let's make comment this, and s n like 1 plus 5, 2 plus 5, 4. So here you can see we are calling this function now multiple times, okay. So add 1 comma 5, 2 comma 5, 3 comma 5, 4 comma 5. So we have written this definition only one time, but we are calling this function multiple times, 4 times we are calling, so no need to write this this part of code 4 times. So So you can write only one times and you can call multiple times. So then you will get the answer. You can see the first statement is printing 6, then 7, then 8, then 9. Okay, in this manner you can call this function from anywhere from the code, and you can run this part, run this block. Okay, so this is the function syntax, function definition, and declaration. So you should know all these things. uh, I hope this is clear. Any query in this? Okay, so there is no query, then the next part. So next thing is, so this other example is also given here. So this is also very similar. So let me just copy this code. So the here purpose is different. So we are writing the same thing. So include that library file. Then here we define square. So sometimes we need to calculate the square. Okay, in our code. So we can write the function for that. We can define. We are taking one input from the function. Okay, we will give this one input, and this function will return the square of that input. Okay, so in declaration you can also do one things. There's no need to define the name of the input variable. So in only the declaration part. Okay, so you can just mention that this is the return data type, this is the function name, and we are passing one integer value. So okay, so you can just pass the type only. So if you are taking two types, so just mention like 2 times int. So in the previous code, we can remove the A and B from the declaration part. So this is also correct. We can represent in this manner also, this declaration. Okay. So here you can see if we are declared in this manner, but in definition, you have to write the variable names because you have to read the value by some name. Okay. In your body, function body. So here you can see that when we are writing function definition, so we have defined the variable name, and inside the function we are returning this num into num. Okay, so this value, and now in the main function you can see we have defined the int result equal to square of 4. So 4 square is 16. So that 16 should be print in the output. So if you run this code, you are getting square equal to 16. So that means this is printing. Another things what you can do, if you are printing the output in the main code. Okay, so what you can do, you can also print the output inside the main function. So just write the code here. So in this case, suppose you want to just print the square value from the, okay, so you can also write the code in this manner. But in this case, you can see this compiler is showing one warning. Yeah, so non-void function does not return a value. So here we have defined the return data type, but we are not returning anything from the functions. So in this case, some if you feel that function is not returning anything from the code, so you can change this data type to void. So void. Okay, same in the declaration here. So void. Now, and also here we are using result equal to square 4. So that means this function is not returning in the code, not returning anything in the code. It is just printing something, okay, into the output console. So at that time, there is no requirement to read the input because it is not returning anything. So we can simply write the call. So square 4. So in this case, what happening? That when we are calling this function, so we are passing 4 value. That 4 value will be assigned to this num. Okay, and this num value will be passed to the statement. So num into num, 4 into 4, 16, and that this print statement will be provide the output in the console. So if we write this, you can see we are getting the same output from the function. So if you write this multiple times, so like, and yeah, okay, new line is there. So like 2, 3, 4, and 5. Okay, so now we are calling this function 4 times, so you will get output 4 times. So square 4, 9, 16, 25. Okay, so you can also do these things. If your function is not returning anything, you can just mention the return type void. Okay, so in this manner you can write the definition of function. And suppose if your function is not taking any input and it is performing some specific task, okay, so like display, if I just change this function name like as a display, uh, okay, okay, and inside the definition I am just writing some message. Okay, so like hello C. So what we can do, we can leave this empty, and this name is now display. So we will change the function definition name also, and from here we need to call this now. Okay, so now we are not passing anything as a input into the function, but when we call this function, this will only print this hello C. Okay, so if we call this multiple times, so like this, so you can see when we call this, so it will print 3 times hello C. Because we are calling from here, this no input is required to this function, and this is just printing something. So this is calling, and this print statement is executing. Okay, when we are calling this, so at that time you can leave this bracket empty. So okay, and here we are not returning something, so you can use this void return type. If you want to return something, so mention the data type. Okay, so now this is the things. The next thing is different ways to pass parameter to the function. Okay, so parameter to the function. Okay, let me just read the code again. Huh. So how we can pass the parameters to the function? So what type of value we can pass in our function? So actually, generally we use two types of parameters passing. One is call by value and call by reference. So that this reference part will be discussed in the next week when we will discuss the pointer. Okay, but I'll give just very basic information regarding this to just explain. So suppose this is the main program. Okay, so if you are passing direct value to the function, and that value is assigned to this variable. Okay, so this value we are passing, and this value is passing, and this is assigned to num. Okay, so here what happening, actually we have just created. So let me just copy this code. Okay, so what happened in this, so actually when we're calling this function square 4. Okay, so this is a value, this value, and here when we are in the definition, we have defined one variable num. So that means we have one memory for this num, and that memory block is actually some memory location inside the memory, and this num variable is actually pointing to this memory location. So when we are calling this, so this 4 value we are passing into the function, so this 4 value will be assigned to this memory place. Okay, so which is allocated to this num variable. So 4 value will be assigned here, and then you can just use this variable name in your function. So that means 4 will be used inside the function. So this is called as a call by value. And you can also pass this like you can suppose if you have right here int n. Okay, n equal to 4. Okay, so here you have defined one variable n, and you can pass square n. You can write n also. So here you have defined you have already defined one assigned some value for the n, and then you are writing the variable name here. So that is also will be called as a call by value, because the value of that variable is passing to the function, and that value will be assigned to the inside the memory allocation, which is defined uh, that variable which is defined inside the definition. Okay, so to the num. Okay, so this is the one part, call by value. Another thing is call by reference. So what is this call by value? So you can see call by value example here in this code. So we have defined one function, this increment. It is taking one integer value x, and it is incrementing the value of x and printing. Okay, here we are calling this function from this main code. So and we are passing num. Okay, num, and num is equal to assigned to 5. So that means this 5 as a value is passing, and that value will be assigned to x, and that x we are using inside the function. So this is called as a call by value. And call by reference, or sometimes we call it as a call by address. So each memory location have some address, okay, to access. Okay, so for this part, so let me just change this. So if I write this int n equal to 4, okay, and inside this function I'm just writing the example of call by reference. So here to store reference means we want to pass the address of the memory location, and that address will contain some data. Okay, that memory address will contain some data. So address can be stored in pointer only. So, okay, so pointer, and so we have to define one pointer in the definition. So we will define like this int asterisk. We have also defined in the definition. So int asterisk here, and so what is the meaning of this? When we are writing this asterisk num, so this is called as a pointer, and pointer is also a variable, and that variable only contains the memory address. Okay, as a value. So now we want to call this function, and we want to perform this operation. So what we can write this? So asterisk num into asterisk num. We can write like this. So we will discuss these things in the detail, pointer things in the detail in the next 2 weeks. So I'm just giving one example. So now we will not pass the value here. So we have to pass the address. To access the address of any variable, we write this end symbol. Okay, so end n. Okay. Now when we are writing end n, so this is actually representing the address of this n. Okay, so what happening in this code? Okay. So in this code, actually, when we are writing int n equal to 4, okay, so that means some memory block is assigned to this n, okay, and 4 value is stored in this block, and it also contains some address. Okay, it may be represented in binary, decimal, or hexadecimal. Okay, so I'm just taking some example like this 10002 is the memory address. Okay, so this is the memory address. 1002 is the memory address of this location. Okay, where the 4 is actually stored. So this address is stored when we are passing this end n. Okay, so this value is representing this address 10002, not the value. Okay, when we are writing this end n, so this is actually a address of memory address of this n, where the n is pointing. So this n will contain this memory address 10002. This address we are passing into the function. Okay, and this function is actually receiving by a pointer. So this is a pointer here. Num is a pointer that is containing this address. Okay, so 10002, this is the memory address. Okay, and where if we want to access the value of that pointer, so we have to refragment the dereference. Okay, so dereference, so here this num is actually containing a address, but we want to read the value at this address. So we have to write in our statement like this, so asterisk num. Okay, so this is only at the declaration time, so where we are using this asterisk num. But when we are writing in the statements, so this is actually dereference, so that means it will return the value at that address. So that 4, and this will also return the value at that address 4. So 4 into 4 we will get the 6. Okay, and then that 6 will be printed in the output. So here we are passing the address of memory location in the function, and we are performing the task on the address. So at that time you will get the same answer. You can see you are getting the same answer, 16. Okay, but this is called as a call by address. Okay, we are passing the address to the function, not the value. Okay, so these are the two types of calling. So based on your requirement, you can pass the data types, you can direct pass the value, or you can pass the memory address of that value. So that concept we will discuss in the next week. Okay, so don't worry. And next part is, so this is called by reference. I have declared this. So this you can see same increment operation we are writing here now, and we are calling num equal to 5, and we are passing the address of this num. Okay, and symbol, and we are receiving this in the pointer, and we are reading the value at that pointer and then incrementing. Okay, and after that, after, so we are updating that value at that location, so we are printing that value. Mhm. So in this manner we are using the call by reference. Yeah, next thing is recursion. So is this clear, this function call by part? Any query till now?
Sir, we can use asterisk n also.
Where?
The last one which you.
Okay, 1 second. This one.
Yeah,
Hmm.
yeah. In the return, there we can use asterisk n. No.
No. So we are actually using the variable which we have defined inside the function. So num, we can use that variable. We cannot access the n variable directly inside the function, because this thing we also discussed in the last part of this content. Okay, scope, actually that is called as a scope, which part we can access from the other part. Okay,
Okay, sir. Okay.
so these things, this is now, next thing is the recursion. Yeah, this is also one important concept of the programming. So recursion, so now you know that what is the program, and we how we define the function, and how we call the function from the other part of the code. Now what is the recursion? Recursion is a programming techniques where the function calls itself. So we will write the call statement inside the body of the same statements. Okay, so that means if you're defining a function, so like if you're writing a function, and function name is like x. Okay, and we have defined like this void, these things, and we are writing some body. Okay, so here this is the data type, return type, this is function name, and this is empty brackets. But what happening, we are calling this function from the same function body. So when we are writing some statement inside this body, at some part we are calling the same function from the body. Okay, so that means this function is calling itself. Okay, so we are calling the same function itself again and again. So this is called as a recursion. So now, uh, hmm. so what are the requirement things for this? So sometimes actually very complex problem we can solve using the recursion concept very easily, by very little code. So some games, so if you know that one game is popular game is Tower of Hanoi, so if you don't know that, you can search it. So you cannot solve that problems by the some basic codes, but we can use the recursion techniques, and we can solve that problems in maximum 3 or 4 line code. Okay, so many problems we can solve using this concept, is very small codes and in the very simpler way. So what are the key concept of the recursion? So this is the definition. Recursion is a programming technique where the function calls itself. So function call the same itself. Okay, so what are the key concept of the function? So first is base case. So because we are calling the same function from the body, okay, again and again, so that means we have to define one base case some after some recursive call. Okay, after some repeatedly call, our call recursively call should stop. Okay, otherwise our that call things will be go into the infinite depth, infinite call. Okay, so suppose if you are writing this like this code, we are not writing any base case, and we have written this like, okay, void x, and inside this function we are calling the same function. So what happened, we are starting from some input and we are running this code. So first time we have to call this function from the outside, but after that this function is running inside the body when this statement will execute. So that means one new code will be executed. So this block will be code run again. Okay, so same things again, same call. Okay, so this block of code will run again when we are calling from the inside part. Okay, again when we are running this, once the call will be received, so one same code will repeat again. Okay, and once again we have the call statement. So in this manner this code will run in the infinite times. Okay, it will not stop. So we have to define some base case. So if sometimes our base condition is true, at that time we will not call this function again. Okay, so that is the termination condition we have to define inside the body of the function. If that condition is satisfied, at that time we will not call recursively same function again. So that is called as a termination condition or base case of the function. So that should be defined, that base case should be there in the recursive function, otherwise your code will always run. Okay, so when you're designing any recursive function, when you're writing any recursive function, so just keep this thing in your mind. You have to define some base case. So after some recursive calls, repeatedly recursive calls, your base case should be executed to stop the recursive call. Okay, and this is the first things, base case. Second part is the recursive case. So this is the part where we are calling the same function again. Okay, that is called as a recursive case. So when we are calling the same function again, so suppose we are getting some input from the function. Okay, suppose we are getting some input n or something from the function. So when we are calling the same function again repeatedly from the recursive case, so our input of the function should be moved to the base case side. Okay, so what base case we have defined, what termination condition we have defined. So in each call our input should be moved to the closer to the base case. So after some number of repetitions, our base case should be satisfied. At that time our that recursive call will be stopped and our code will terminate. Otherwise your code will not terminate if you have not well defined this base case and recursive case. So this is base case. And next thing is the stack memory. So how actually that memory is allocated in the recursive calls, so that we will just take one example in the one editor. Okay, that I'll explain later. Okay, stack memory, how the stack is actually memory is allocated to the each call. But before that we will discuss some examples to understand better. So let's I'll take this code and I'll just explain that. This is simply factorial calculation. How we can calculate the factorial by recursive code. You know that what is the factorial? So factorial value, suppose if you are getting in input, so n equal to 4, so what should be the factorial of this 4 is 4 into 3 into 2 into 1. Okay, this is the value 12, 24, 24. Okay, so in this way you can calculate the factorial value, just for multiply the all value from n to 1. So how we can solve this using the recursive code? Okay, so I have said, I have mentioned the incorrect. One second. Okay, let me just copy again. Okay. Yeah, so okay. So now this function, you can see we have defined one factorial function, and this is a recursive function. So you can identify this function. So this name is given as a factorial. Okay, and it is taking one input, and inside this function we have defined one base case. So this is called as a base case. If at any time, if your n value is equal to 1, or n value is equal to 1, sorry, 0. Okay, so if our n become 0 or 1, at that time we will return 1 from the function. Okay, so this is a base case when we are not calling. If this condition is true, first condition is true, then we are not calling this function again. Okay, so we are simply returning 1. Else part, if the above condition is not true, so we are performing the else part. In else part, we are calling the same function again. Okay, so this you can see n into factorial n minus 1. So here you can see this is a call. Okay, so we are calling the same function name factorial, and we are passing n minus 1. Initially it was n, but now we are passing n minus 1, one value less. So you can see if we start n equal to 4, so inside this function we are calling n minus 1, that means 3. So in one call this input is decreasing. Why this is decreasing? Because we want to satisfy this base case, because our n is assigned, base case is assigned as a n equal to 0 or 1. So that means our input should reach to either 0 or 1. So that means each time we should decrease this value in the input, so we will reach to the base case and we will return this one without calling again. Okay, now logically how this call happens. So initially you can see that we are starting from num equal to 5. So this is the main function, and we are writing result equal to factorial num. Okay, we are calling this function first time. So when we're calling this function, our call is happening from here. Okay, because this function contains the return statement. So after execution of this factorial function, it will return something, and that value will be assigned to result. But we will just understand the recursive structure of this. So we are writing, I am just writing the base. So that means we are calling this function factorial. Okay, I am just writing this function as a f. Okay, so just assume that this is a factorial function f, and we are passing 5. Correct. So f5 we are passing inside this function. Base case is written here, but base case is not satisfied. Okay, base case is not satisfied because n is equal to 5, not 0 or 1 in this case. So I have mentioned this cross. Now recursive case. So recursive case is recursive case. Okay, so this is now will execute. So this is not satisfied, so this is will be execute. So recursive case is written like return n. Okay, so what is the value of n currently? 5. Okay, so we are receiving as a n equal to 5 here. So that means I will replace this as a 5 into. Okay, and this is the second part. So now we are calling the same function f, and we are passing n minus 1. So what is the current value is n minus 1? This is 4. So now this is the new call. When our compiler is executing this statement, return 5 into this function call. So our control will be moved to the next call. Okay, so this call should be performed first. to perform this operation. We cannot write 5 into this f of factorial 5. Okay, we cannot multiply this because we need the return value from this function. So this function will execute first now. Okay, so same things. Now we are calling again. So f4. Okay, now we are passing n equal to 4. So I am writing like n equal to 4. N equal to 4 here. And inside this, base case is not satisfied because this value is not equal to true, but recursive cases will perform. So recursive case is return n. So what is the current value of n is 4. So 4 into then again f3. Okay, so 4 by n minus 1. So 4 minus 1 become 3. So now once again the control will move to the new call function. So now this time we are passing f3. Again base case is not satisfied. Okay, next else part will be run. So return current value of n is 3 into f function call with n minus 1. So 3 minus 1 2. Okay, now again this is a call, so our control will move to the next call. So f2 and same, still n equal to 2. Okay, so this is n value, n equal to 2. Base case is still not correct, so we will write return 2 into f1. Okay, now this is again one new call, but this time f1 you are reaching to 1, and this time n equal to 1, and this is satisfying the base case. You can see n equal to 1, so this second condition is become true. So if any condition is true in the or with the or case, so our overall expression will be true, and that means our base case is now true and we will return 1. Okay, so that means this last function we are not calling the function recursively again, so we are directly return 1 from here. Okay, so this is now the termination condition. So here this last function f1 is actually returning 1, so this 1 will replace this value. Okay, so f1, because this is the last function called, this function f1 will be written 1, so this will be replaced from 1 here, so this 1, so 2 into 1. Now this expression will be solved. 2 into 1 is now 2, so overall will become 2. Now f2 function will return 2 to the previous call where from we are calling this function, so this part will be replaced by 2. Okay, and this 2 into 3 operation will be performed and you will get 6 after multiplication, and this 6 will be replaced, so this return 6 and 6 will be replaced this f3 part. Okay, call, and this 4 into 6, this will become 24. That means your function is now returning 24 to the previous where we are calling, so that will be replaced by 24, and 24 into 5, this is now become 120, and this function is the main function where we are starting from. Okay, so we are getting return 120. Okay, so now this part is complete, recursive function, and return is still 120. So you will get 120 from the main call. So main call is starting from here, so this main call is returning finally 120, and 120 will be replaced here, so 120, and this 120 will be assigned to result, this result. Okay, and that result and num, so num is now 5 at this time, and result is will be replaced by 120. This will be printed in the output. Okay, so in this manner function is actually perform, recursive function is executing. So if we run this code, you can see okay, so type of recursion, not this recursion.
Sir, we have to write base case of the main case, main program.
No, so that means let me just run this and tell you. So you can see you are getting this answer 5 and 120. So this is not required in the coding. So what you can do, you can just write the opposite condition. Okay. So if n is greater than equal to like this in this manner. So if n is greater than equal to 1, you can write this condition in the inside the if statement, then else statement. Okay. So what I can change? So I can write if n is greater than equal to 1. So I'll write this statement at the above. So this is depends on and I'll write this here. Okay. So we are starting from n. So n value may be anything. It's like 4, 5, 10, anything. So if this condition is satisfied, we are calling recursively. Okay. And every time we are reducing our input, so it will reach after some times to the base case. That means this else part should be performed to terminate. Okay. So after some calls, so our n value will become this condition will become false. At that time we will run this else part. Okay. So you can make this base case like as a if else condition based. Okay. So that means after some number of calls, repeatedly calls, your base case should be executed without executing the recursive case. So it will also run in the same manner. You will get the same answer. So this is the calling structure. So how we can logically think of this call. So you can just imagine in this manner how this value is actually called. We are calling first time, then value is returning from the last, and then finally we are getting the value. So you can just write the very basic small recursive code like just to add first n numbers. So that is very easy. So in this manner, and then just imagine how you are getting, and this just write the syntax every time. So when you're calling, just make the arrow and write the complete code. Okay. So which code is actually executing, and then again call, then just write the arrow, just link in this manner. Okay. So you will always get the return value at the point where you are calling from. Okay. So that value will be returned at that place. So this is a recursive structure. So after some practice, so you will get some clear idea of this recursive code also. So just write some very easy code first. Okay, so next thing. So this you can, I have already explained these things, base case and okay. So type of recursion. So what are the types of recursion is? So basically one is the direct recursion. So we have already discussed the example, which is the example of direct recursion. So direct recursion means if our function is calling itself, so that is called as a direct recursion. Another type is indirect recursion. So that indirect recursion is suppose if we have a function a, so like a function we have, okay, and we have some body, and b function we have, okay, and we have some body. From a function we are calling b function, okay, and from b function we are calling a. Okay, so when we are running a, so that means our control is moving to b from this call, and when we are running b, our call is to a. Okay, then once again this will happen repeatedly. So this is also a repetitions of the same block, okay, a and b. So this is called as a indirect recursion. So indirect recursion, we are not calling itself, but we are calling the other function, but from other function we are calling the same function. So that is called as a indirect recursion. Okay, so one example is given. So even and odd. So you can see in this code, from even function we are calling the odd function, but from odd function we are calling the even function. So in this manner, this code, this is called an example of indirect recursion. Okay. And another example we can take, so this is the factorial example type of indirect recursion. Let me just take this example also to just clear the recursion part. So this is another code. So okay, this is just a program to write the sum of first n natural number. Okay, we are passing n value, so that this is very similar to the factorial, but here we are adding the value, not multiplying the value. So if we are getting like 10, so that means we should get the result of 1 plus 2 plus 3 plus 4 like this till 10. Okay, so we are only changing, the function is very similar. So here this is the base case. If our n becomes 0, then we will return 0 without calling. Okay, but if our n is not 0, then we will call recursively and return n plus some direct. Okay, so same things, if we start from the main function 5 and this is the first call, this first call we are calling some direct. Okay, so I am writing sd and we are passing this value as a 5. So in this body 5 we have n equal to 5. Okay, so n equal to 5. So now first base case is not satisfied at this n equal to 5, so we will perform our return statement only. So return 5 plus, so same things you can see, we are reducing the input in the each call, recursive call. So that st 4. Okay, now this, when this statement will execute, that our control will move to this call and the same function run again with the different input. So st now 4, and inside this again base condition is not satisfied, so return 4 plus sd 3. Okay, and from this call again st 3, and inside again base condition is not true, so we will return 3, so not equal to, return 3 plus st2. Okay, now again recursively call st2. So statement base condition is still not true, so return 2 plus st1. Okay, now the next call st1, base condition is still not true, so return 1 plus st0. Now again st, so I'm writing below. Okay, st 0. So now you can see that we are getting n equal to 0 in this call. So this is now equal to base case. So in this case we will directly return 0. Okay, without recursively call. So when we are writing return 0, so this 0 will be replaced to the previous call. So 0, now 1 plus 0. Okay, 1 plus 0 is 1. So now this 1 will be replaced to this. Okay, now 1 plus 2 equal to 3. So 3 will be returned from this call and this will be replaced here. So 3, and 3 plus 3 is now 6. 6 will be replaced to the call 6. Okay, and 6 plus 4 equal to 10. 10 will be replaced to this, and 10 plus 5, 15 will be returned to the main call. Okay, so which is the first call, and 15 will be returned by this main call and it will be right here. So 15. Okay, and 15 value will be assigned to result and that value will be print here 15. Okay, so output will be 5 and comma 15. So similar manner, this is the very similar code. So yeah, this is the type of recursion. Yeah, next part is scope in C programming. So scope means the scope of a variable defined where the variable can be accessed and modified. Okay, so we are actually declaring the variable in the code, define, assigning some value to the code, and we are accessing that variable in our code when the variable that variable is required. Okay, so if we are defining some variable in our code, so where from we can access that variable value. Okay, so that is actually defined by the scope. Okay, so the understanding of the variable scope is crucial for writing clean and maintainable code. So there are three main types of the variable scope in C: global scope, local scope, and block scope. So first is this global scope. So global, as per the name global. So global variable can be accessed from the any part of the code, but it should be declared outside of the function in our code. All functions. Okay, so also the main function. So here you can see that. So the area which, if when we are writing this include stdi.h, so without entering inside the any function, if we declare any variable outside of the functions, then that variable can be considered as a global variable. Okay, so suppose if we are declaring some variable int global var equal to 10. Okay, so this is not declaring any inside any function like main or any other user defined function. Okay, this is totally outside. So this variable we can access from the any function in the code. So main function also we can, if we are writing any user defined function, so we can also access that this variable from user defined functions. Okay, so here you can see, let me just run this code. So this is also very important for the theory questions, your exam questions. Okay, so if we have defined in this manner, you can see global var, and we are reading this value inside the main function. Okay, inside the main function. Now you can see you will get the value print output. Okay, thus if we change this in the code 13, so you will get 13. So that means you are able to access this value inside the main function, but because it is defined outside the main function or in the global space, so that variable can be accessed from anywhere in the code. So that is called as a global variable. Okay, next is local scope. Local scope means variable declared within a function. Okay, so that variable is declared within a function, and that variable can be accessed inside that function, not outside the function. Okay, so like another example. So here you can see we have a user defined function also. Okay, so there is one main function in below. Okay, local that local scope, this is the user defined function. We have given name local scope example. So now you can see we have declared this variable inside the user defined function, and we have assigned this value 5. Now we can read this value only inside the this user defined function. We cannot read this value from outside of the function. So like if I write this print statement here, you will get a error. Then this you can see. So you're getting error, use of undeclared identifier local var. Okay, so in this line we are just writing this local var which is not declared inside this main function. So compiler is not able to identify this variable because it is not defined inside this. This is declared inside the user defined function, so it can only be accessed from the this user defined function. If I make comment this, so you can see that we will get the output local variable 5. Okay, so this print above print statement is actually performing. Okay, and this code is not giving any error, but we cannot access this local var from outside of this function. So this variable have only the scope inside this function. Okay, we can use this function inside this function, not we cannot access this variable from the outside of this function. Same things, if any variable we have defined here in the lower part, we cannot access into the main other function. So suppose if I write this like n equal to 10. Okay, and if I want to print this n here, still we cannot print. We will get the error. Use of undeclared identifier n. Okay, because this is undeclared in this scope, so this compile is giving this error. But we can access this variable in the main function uh, here, like this. And, okay, then one second. You will get the output local variable 10. So you can see we can. So this is called as a local variable. And next thing is the block scope. So block level C also support this block level scope. So block level means inside the function, if we declare any variable inside the blocks, so that variable can be accessed only inside the blocks. So here you can see that we are writing the main function. Okay, and we have written this x equal to 5, and we are maintaining this condition x equal to is greater than 5, but in we have declared the new variable int y inside the block, and we can only access this y value inside this block. So block means this curly brackets. Okay, so this is actually called as a one block. So this y can be accessed only inside this blocks. We cannot access this from outside of this blocks. But if any variable is declared outside of this block, that will be considered as a global for this main function. Okay, so all complete main function. So outside variable can be accessed from inside the blocks, but inside that block a variable cannot be accessed from the outside. So we will get the output for this code. So you can see that we are getting x equal to 5, y equal to 10. But suppose if I try to read this, so here you can see that we are able to read this x value, which is declared outside of this block. So this have the local scope for this function. So this function, this is declared outside, so this can be accessed from the any sub block in this code, but the block level cannot be accessed from the outside. Okay, so if I run this code, you can see that, and we are getting the same error y. So this y is not y undeclared identifier. So this y is defined declared here. So because of that, this is not accessible from outside of this. So suppose if we are not writing this condition also, if I suppose missed, if we just mention this brackets only, still this cannot be accessed. Okay, because this is now a block. But what happen if we declare outside? Okay, and like this only, and now we are assigning something inside. So this is this is okay. Okay, because this is declared outside, and now we are updating this value inside this block. So this can be accessed because this is declared outside of this. So this will be accessible. We are getting the output. Okay, so this is called as a block level scope. One second. So this is a block level scope. So these are the scopes actually which C supports. Another some things are there, so we will discuss later. So like we can make some parameters global for the function. So each function call, we can use access the value of that common variable for the function. That is called as a static tab variable. So that we will discuss in the week 7 or 8. So but this is the basics of the scopes and function recursions. So now this is the last topic. Yeah, so if anyone have any query, any doubt in this, so you can ask. Yeah, Saji, so I'll just paste the I've already pasted the drive link in the previous calendar. So if you just move to this 13, okay, so 13 Tuesday one, So when you open the calendar, you can see notes drive link. Okay, so when you open this drive link, you can see B3, B4, B5. I've already pasted. Yeah, so you can access. I'll also paste this drive link in the today calendar. Okay, just paste. So in today, you can see. Okay, any query? Any doubt in this part? Okay, so again, the request is do not skip or do not forget this timed work assignment in this weekend. Okay, this is very important. Okay,
Sir, if I attempt 50% of question in Saturday and next
yes,
50,
yes, you can do. Okay, so suppose if you submitted the solution for problem 1 and 2 on the Saturday, so that will be submitted and you can see the solution in the next day also. That solution will remain stored.
I,
Okay.
I, I can leave any time in time or full, I have to complete the full time.
No, this is totally not non-proctored. So if you start attempt from 8, you can leave at 9. Okay. So there is
Okay,
no foundation to do.
okay, sir.
Okay, but that assignments will be disappear at the 10 on that day. Okay, so you cannot access after the 10 p.m. Again, next day it will open at 8, then again disappear at 10. So
Okay.
during that time, you can only solve. Okay. Any other query? Any other doubt? So regarding the quiz and qualifiers, so just attempt the Friday session also for the revision. Okay, and also just collect your doubts till the Friday and ask your doubt in the session. Okay, then if there's no query, then we can close the session. Thanks, everyone.
Thank you, sir.